7.7 Basing natural log. So this lesson's about the other special log function. Last time we did common logs, now we're going to do natural logs. And our goal for this lesson is by the end we want to be able to solve log problems using natural log and e. So let's start off by talking about what e is. So e is a special number of mathematics. There's quite a few of them. The most popular one by far is pi. Everybody knows what pi is, right? The ratio of the circumference to the diameter is 3.14159. Blah 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 blah. Just like pi, e is a special number. E is a number 2.71828, and likewise goes on forever without repeating. So there are two special numbers in mathematics, pi and e, right? Well, two of the most popular special numbers. There's a lot of special numbers in mathematics. Okay, so why is that important? Well, if you remember from the last lesson, we have a couple of special logs also, right? The most, like log without a base, right? The common log we talked about last time. That one's a special one, that is log base 10. And in this lesson, we're gonna learn the other special one, which is this. A log with the base of e is the same thing as what we call the natural log. And the way we write that is ln, so ln a. So that's the natural log, right? So log base e is the same thing as ln. Just like how log base 10 is the same thing of just log without a base, right? These are so special that we use shortcuts to write them because we're going to use them so often. So we don't want to write log base 10 all the time. We're just going to write log. We know that means 10. We're not going to write log base c all the time. We're just going to write ln because we know that means natural. That means log base c. And since that is the case, all the rules of logs follow through, right? Let's talk about the two most important ones. Remember how in logs the base and the number match? They cancel out. You just get 1. Well, the same thing here. If you have log base e to the e, they're going to cancel out and you just get 1. But we don't write it that way, right? We write it with the ln instead. So this is ln of e, right? Because that's the same thing as this, equals 1. And that is a big, big result. ln of e equals 1. Keep that in mind. So anytime you see natural log e, they reduce to 1. Likewise, our favorite rule, right? If it's b to the log base b, those reduce and you get the variable, whatever that is, x in this case. So if you have e to the log base e of x, well, those will cancel out. You just get x because they're the same. Well, the way we write this in natural log would be e to the natural log of a, or x, whatever. You get the point. These would cancel out and you just get a. Other than that, so e and natural log always reduce and get you a. Natural log and e always reduce and cancel and get you the value. Other than that, all the basic natural log rules apply. Natural log of a plus natural log of b, well, they're just logs, so when you add logs, you multiply them. Natural log of a times b. Same thing we subtract, because they're just logs, so all the log rules apply. Natural log of a over b. And my favorite rule also comes over. Natural log of k, well, you can move that to the front, just get k natural log of a. A little issue writing that, but that's what goes on. So all the basic log rules apply. Now these are a little special because we're going to use these a lot more, but natural log of e cancel out, e natural log cancel out, you just get the value on top, and here's the value on top, which is just 1. That's the general idea. Right, just a little note on this, remember that's just because the power here is 1. If I had natural log of e to the x, those would reduce and you just get x. So it's just similar to this. Let's solve some problems. As we just discussed, right? E natural log x equals x. These can reduce and cancel out. Natural log e right here reduces and cancel out. And that's kind of our whole goal for today's lesson. We want to be able to solve e and natural log problems. So here, let's just rewrite it first to make sure we know what's going on. I want you to understand that, hey, there's an e there. Let's get rid of it. Let's take the natural log of both sides. On this side, I have natural log of 30. On this side, the ln and the e reduce. You just get x. Same thing here. I'm not trying to solve it. I just want to rewrite it. So let's get rid of that e again, right? We're taking the natural log of both sides. These will reduce, you get 3 natural log of x. Again, wasn't trying to solve for x, it was already solved. Just trying to rewrite it. So let's solve these problems. Or rewrite, okay, let's rewrite these natural log ones now. Right, so we know how to rewrite e once. Take a natural log both sides. How about you have natural log? Well, same idea as like when we do a log. Right, if I have a log 3 of x equals 4, the way we solve this, or rewrite it, I should say, is you get the base to both sides. That cancels out. Well, the same thing here. Remember, natural log is the same thing as log base e. So we're going to take the base of both sides. We're going to take e to both sides. These will reduce, and you get x equal, x is approximately, that's an approximate sign. So it's about e to the 2.1438. So that's an approximation sign. So look at right here, right? Oh, there's a natural log. Let's reduce it. Take the e to both sides. So 18 equals e to the x. And that's going to be your whole goal. You see a natural log, you want to be able to take e to both sides. You have an e in your problem, you want to be able to take natural log both sides. Now to get to do that first, we have to reduce. And before into practice our old rules, let's condense some natural log problems. Remember, by condensing I mean we want to make it a single log. We want to go from like something like this, or 2 natural logs, to just a single natural log, into that effect. So using all our rules, adding is multiplication, subtraction is division, and my power goes to the front or back, vice versa. So like here, remember the first thing we always do is the powers here when moving to the top. So natural log of 8 to the 6, heck if I know what that is, minus natural log of 4 squared. That's a minus sign, so we're going to divide. So again, the key is it's 1 log, natural log of 8 to the 6 over 4 squared. Again, it's 1 log. I hate when people do this. Wrong. Now, that's done. We actually could reduce it, because we're pro. 8's the same thing as 2 cubed. 4 is the same as 2 squared. Now remember, power to power you multiply, so I actually get natural log of 2 to the 18th over 2 to the 4th, which is going to give me natural log of 2 to the 14th. That's some power skills right there, right? You write 8 as 2 to the 3rd, 3 to, remember power to power you multiply, so 2 to the 18th. You write 4 as 2 squared. 2 times 2 is 4, so 2 to the 4th, subtract 2 to the 14th. Again, this will give you lots of credit. This will give you full, amazing credit. Let's look at this one. Same idea, let's condense it. Let's practice condensing. First, these powers go to the front. I love that rule. So natural log of 5 squared, which is 25. Natural log of 2 to the 4th, which is 16. Plus natural log of 5y. So we have all this, and it's all plus. That means multiply it all. So I'm write one big natural log, and then 5 squared times 2 to the 4th times 5y. I don't know what that is. I'm just going to leave it like that, though. Same idea. Right? To quickly, let's make sure we understand this, right? Let's rewrite this. Again, first thing's always the powers. So natural log of 3 to the 5th minus natural log of 9 squared. Minus means divide, so natural log of 3 to the 5th, whatever that is, 273, I want to say? Yeah, 273 over 9 squared. So now, since I know what that is, that's natural log of 273 over 81. That actually reduces the divide both by 3. Probably could have done that up there. Yeah, natural log of 81 over 27. That actually reduces some more. Natural log divided by 3 again. Actually, divide by 9. Let's do that. Stop taking baby steps. 9 over 3. And that actually reduces the natural log of 3. Took me a while to get there, but that was just natural log of 3. I should have gone like this and been like, hey, that's 3 squared. Which is 3 to the 4th, 3 to the 5th. That just gives me 3. But whatever, I got there eventually. Natural log 3. Sitting here, right? Bring this to the top, bring that to the top. Natural log of 5 cubed, 125, plus natural log of x to the 4th. This is 125. Plus means multiply. Natural log of 125 times x to the 4th. Done. Right, so now that we practice condensing and solving, because remember when we solve, now that we practice condensing, let's practice some solving. So remember the general rule is, right, if you have e to the x, you want to be able to take a natural log. If you have natural log, you want to be able to take e to the x. But like solving any problem, first thing first is isolate either e to the x or natural log of x, right? Isolate. And again, notice, by the way, guys, notice I put natural log of x. Don't just ever put natural log. That makes no sense. It's natural log of something. Look at your calculator. When you take a natural log, turn this on. Natural log is of something. It's never just natural log by itself. That makes no sense. It's natural log of something. So x, a number, something. So look at this first one. E to the x equals 30. Get rid of the e to the x. Take natural log of both sides. Gone. X equals natural log of 30. Done. Easy. This one's natural log, right? Want to get rid of it? Take the e to both sides. Done. X equals e to the 42. Let's move on. A little tougher. Like, oh, there's more stuff there. Oh, what am I going to do? Well, you're just going to add 24 to both sides, right? Try to isolate this. 5 to ex equals that 24 plus 16, so blah, 40. Now here, again, still cannot take natural log. There's a 5 there. Get that 5 out of the way. Divide by 5. Ex equals 8. And now, ex all alone, perfect. Take natural log of both sides. These cancel out. X equals natural log of 8. Natural log, just like when we talked about logs, natural log of x has to be greater than or equal to 0. Greater than 0, I should say, not equal to. Same domain as a log. Over here, right? Same concept. Let's get e by itself. So let's add that 3 over. Get out of here to 3. Now we're going to divide by 2. I don't care if you leave it as 11 over 2 or if you want to reduce it to 5.5. We can get rid of the e, so let's take the natural log both sides. Negative x equals natural log of 5.5. Then we could divide by negative 1. Now this is cool still. Right, the inside can be negative. Outside natural log could totally be negative. You can have a negative answer, you just flip it along the vertical axis, the x-axis. Now let's look at some natural log problems. Natural log of 3x equals 8. So remember, the way you want to get rid of natural log is you take the e to both sides. So take the e to both sides. 3x equals e to the 8th. Now we can just divide by 3. X equals e to the 8th over 3. Done. Standing over here, but just like before, you always want to isolate the natural log. Get rid of that negative 4. Natural log of 2x equals 20, cancel out, 26 over 4. Also known as 13 over 2. So let me rewrite that. What we do next is what we always do, right? You want to get rid of natural log? Take the e to both sides. Now that's all alone. 2x equals e to 13 over 2. I'll get rid of that 2. Either multiply by 1/2 or divide by 2. And there you go. X equals e to 13 over 2 divided by 2. How do we solve inequalities? Well, it depends. So e's are exponential problems. So you don't have to worry about domain. Domains are all real numbers. So that means you just solve it like normal. So we're going to subtract 5. E to negative x is greater than 9. Nothing changes here. Take the natural log both sides. Negative x is greater than natural log of 9. We can get rid of that negative, so let's divide by negative 1. Remember when that happens, we flip our sign. That's it. You're done. Nothing to worry about, right? Again, when it's an exponential equation, always just solve it like normal. Nothing changes. When it's a log equation, though, then it matters. Because there's the domain. Natural log of x has to be greater than 0, just like log. So in this case, you got to do the domain first. So this right here, x plus 5 is greater than 0. X has to be greater than negative 5. Remember that there's always the domain you got to worry about when you're doing logs and natural logs. Other than that, we're going to solve like normal. So how is that? A lot of people want to square root this. Technically, it's okay. But really, what you want to do is bring the 2 to the front. Then we're going to divide by 2. So you have this. 6 over 2 is 3. Now let's get rid of the e. We take the we'll take the e to both sides. So you have x plus 5 is less than e to the third. Now we're just going to subtract 5. So subtract 5, sorry. So we have this, and we have this. You must be less than e cubed minus 5, which you put in your calculator and get an answer if you want. You must be greater than negative 5. So you have to be between those two. Right? Natural logs and logs are always extra steps because of the domain. You can't have negative numbers. That affects your answer a bit. Exponentials, your domain's all over numbers. You can plug anything you want into there. So it doesn't affect your answer at all. You just solve it and you're done. That's how you do it. Okay, let's finish this lesson. First thing, let's write an expression. Let's expand a natural log, right? So earlier, before we started solving, we talked about how to condense it. How do you bring two natural logs into one natural log, right? So you do all the powers, bring the powers up. Plus means multiply, minus means divide. Let's go backwards now. I'm going to give you a condensed one. I want to separate it. So like here, you look at it and you go, okay, I have 12 being multiplied by x squared. So I know multiplication is addition. So let's separate it. Natural log of 12 plus natural log of x squared. You're like, good, done. That was easy. Don't forget one last thing. This is not fully condensed yet. You gotta do my favorite rule. Bring that to the front of the natural log, this one here. So natural log of 12 plus 2 natural log of x. Now you're fully condensed. Over here, so, right, divide means subtract. So let's do that. Natural log of 16 minus natural log of 125. And you're done. Unless you want to be a go-getter and like rewrite this as 16 is 2 to the 4th minus natural log of 5 cubed. And then you can move that to the front. 3 natural log of 5. But they're the same thing. They didn't show you powers, you don't have to write it. So that's good. This is a little better. Let's solve let's talk about some application problems with e's and natural logs. So first one here, a virus is spreading through a computer network according to the formula vt equals 30 e to the 0.1 t, where v is the number of computers infected, right? Always important. What do the variables mean? So v is the number of computers affected, and t is time. So look at what it wants us to do. How long will it take for the virus to infect 10,000 computers? So that's my v. I'm looking for time. How long? Time. Right, so I have my equation here, plug our stuff in. 10,000 goes in here, equals 30 e to the 0.1 t. And how do we solve this? Just like we know how to solve it. Get the e by itself. So let's divide by 30. Remember the application problems we're going to use for some calculators. I'll do that in a second. Always want to use a calculator into application problems. That number's going to be realistic and ugly. So you get this. I want to get rid of the c, so let's take the natural log both sides. So I'll use my calculator in a second, my handy dandy calculator. These cancel, you get 0.1 t equals, I don't know what that is, let's use a calculator. So turn it on every single time, bane of my existence. Let's do natural log of 10,000 divided by 30, right, all one log. And I get, let's round to the nearest hundredth, 5.8. And then I get t by itself, so divide by 0.1. And that should get me to move over the decimal in one spot. It's going to give you t is about roughly 58 minutes. So in less than an hour, it's going to affect 10,000 computers. Isn't that virus a pain in the butt? Okay. And finally, let's talk about some more application problems. Compound interest. Now we did principal interest last time. Now let's talk about some compound interest. So this is the interest that keeps on adding up. So it keeps on adding to your total here. So as always, we have to know what everything means. So A is always our like total, or we call it a nudity. I can say that properly, but it's just how much money you have. It's just the total amount at the end. P is principal, right? So that's just your initial amount. And then R is rate, as always, in percent. And T is time, in years, according to this. That's it. A lot of people say this is APERT. As always, I'll give you the formula for APERT here. But it's just a formula you use and plug it in to figure out how much continuous interest you're going to use. So let's solve some examples. So again, we're going to use this formula. I'll give it to you. look what they give us. If they invested $8,000 at 3.7% interest, so already I have my investment, my P, my principal initial amount, have my R. Remember, move it over to make it a decimal, so 0.0375. Compounded continuously, how much money would be in the account 30 years? Give me my T. So everything I need. If I deposit $8,000, E to the RT at 0.0375 times 30 years, how much money would I make at the end? How much money would I have at the end? So we're just gonna plug this in. 8,000 E. So E's right here. It's under ln is a natural log, by the way. We didn't go over that, but sorry. E's right there in blue. So E 0.0375 times 30, and you get about 24 grand. So you make quite a bit of money, much better than we did before. Well, I forgot what the decimal was. Let's show you. Sorry, I forgot about a natural log. If you want to feel like the natural log of 5 is, you take the natural log. That's what ln is, and there you go, natural log of a number. This is the next set of problem. Same idea, just a different setup. So again, we have APERT. If you can only deposit 10,000, only deposit 10,000. Oh, the horror. If you can only deposit $10,000 into an account, at what rate? So looking for a rate now, very different. Would the account need to grow in order for Angeline to have 30 grand in 18 years? I think the step 12, this was her grandparents. Okay, whatever, doesn't matter. So she wants to have 30 grand at the end of the years, and she can only, for her, can only deposit 10,000 at the very start. And she wants it to be 18 years. So this is her A. At the end, she wants to have 13 grand. We have her P, we have her T, we just don't have R. Just plug it in. So 30,000 equals 10,000. E to the R, which I don't know, and then 18. So that's a little different, right? Last time I just plugged in and got my answer. This time, I gotta solve for E. I gotta get rid of that E here. So what I'm gonna do is get the E by itself, like we always do. Divide by 10,000. So this is 3 equals E to the 18R. Now we gotta get rid of that E. Remember the way we get rid of E? Take the natural log of both sides. Over here, these cancel out. I get natural log 3, which I'll figure out in a second. Use my calculator. It was 18R. So we gotta figure out what that actually is. A natural log of 3 is 1.0986. And then I'm going to approximately, because I rounded, divide by 18. Now my calculator, I'm just going to leave that in there, right? I have my answer. I'm going to use that. Just leave it and put divide. It stores the answer right there by 18. Hit enter, and I get about 0.06103. So 0.06103 is about my R. What rate? So my rate would be about 6.1%. This is the rate I need to make 30 grand by the end of 18 years. And the final question: if Angeline's grandparents found an account that paid 5% interest, good, not bad. Ooh, that's highlighted, not crossed out. Continuously, I want her to have 30 grand after 18 years. How much would they need to deposit? So very similar to before, right? Now they found something that has 5% interest. They want her to have 30 grand when she gets out, when she turns 18. So how long would, assuming that they did it when she was born, how much would they deposit at the very start? So again, same kind of idea. APERT. They want her to have 30 grand at the end. So 30 grand. We don't know how much they want to deposit, so that's our P. We're looking for P this time. How much do they deposit into it? I have everything else. E, I have R, 0.05. And I got 18 years. Now, this was another easy one. I'm looking for that. Well, I can plug this all into my calculator. So you get your handy dandy calculator out. You go, okay, what is E down here? 0.05 times 18. That alone is going to be 2.45. So I got 30,000 equals P times 2.45. I should say roughly. Just divide by that. and I get, let's see, 18,000, 30,000, sorry, divided by my answer there. So you could just highlight your answer, or you could actually put the second answer, and it'll get you about 12 grand, 12.197. So they need to deposit $12.197, and I think it was 8 cents and 9 cents roughly. So that's how much they should deposit. They want her to have 30 grand at the end. So shouldn't we all have grandparents that helpful? Anyway, that's it.